In this video, we're going to talk about the contrapositive and the converse of a conditional statement, as well as the biconditional. So let's first start with the contrapositive. I know that if an animal is a rabbit, then it is a mammal. And then if you know that an animal is not a mammal, can it be a rabbit? Well, let's take a look at this picture. Here I have the collection of all the mammals in the world inside this blue circle. Some of them are hiding, but trust me, they are there. And then you see, if I encircle all the rabbits, are going to be inside this pink circle. So if it's a rabbit, then it is a mammal, right? But if you're not a mammal, if you're not inside the blue circle, there is no hope for you to be a rabbit. And these two statements are logically equivalent. So the contrapositive of a statement of the form if P then Q is a statement of the form if not Q then not P. And they're actually logically equivalent. An example, and this example is going to show you the power of the contrapositive. So suppose that x is an integer, and the contrapositive of the statement if x squared minus 6x plus 5 is even, then x is odd, is that if x is not odd, then x squared minus 6x plus 5 is not even. But of course, we know that integers are either even or odd. So if you are not odd, you're even, and if you are not even, you are odd. So we can rewrite a contrapositive as if x is even, then x squared minus 6x plus 5 is odd. And this is very easy to verify that is true. The original statement was actually quite difficult. Like, at a glance, a simple look, I wouldn't be able to answer whether it's true or not. But the contrapositive, immediately I can see, oh yeah, x is even, so x squared is even, 6x is even, 5 is odd. Okay, the whole thing has to be odd. So it's very easy to verify. So very often, you're going to be faced with statements that you have to maybe prove or show that they're false, that look very difficult. But then when you look at the contrapositive, which is equivalent, they become actually a lot easier to work with. So keep that in mind when you're doing proofs. If a direct proof seems too hard, maybe try to look at the contrapositive. But we'll talk more about proofs by contrapositive in a future video. Okay, now the converse. The converse of a statement of the form if P then Q is a statement of the form if Q then P. So, for example, the converse of if it's a rabbit then it's a mammal is if it's a mammal then it's a rabbit. The first one is true, rabbits are mammals, but if it's mammal is rabbit is false. Dogs, mammals, dolphins are mammals, and they're not rabbits. This is false. So you can see the converse is not logically equivalent to the original conditional statement, right? In this case, the statement was true and its converse was false. But now, let's take a look at this. So if I look at the statement, if n is even, then n plus 2 is even, and I want to find the converse would be that if n plus 2 is even, then n is even. And in this case, both of them are true. Any even number plus 2 is even, and if you have n plus 2, you subtract 2, you end up with n. So it's also true. So both the statement and its converse are true. So in this case, we can combine the two in the following way. Well, we say that n even implies n plus 2 is even. And then now we can draw like a backward arrow because now we're going the other direction. So if n plus 2 is even, then n is even. And we combine the two using this symbol. It's that double arrows, is like a left and right arrow, remember, with two lines. And we read these as even only if. So if P then Q and the converse if Q then P are both true, we say that P if and only if Q. And that tells me that they are equivalent. So this brings me to the definition of biconditional. So biconditional statement is the conjunction of a conditional statement with its converse. And we write it as P if and only if Q. And we denote it by either doing P with this arrow with pointing both left and right, or by writing P if with two F Q. So P I F F Q. And what it means is that P and Q are both true or both false, always. So they're logically equivalent. Like talking about P and talking about Q is really the same thing.